All right, everybody. Can you hear me?
Yes, Professor.
Okay, very good. All Zoom meetings are now starting with that question because I can never tell. All right, welcome to the class. Let me adjust mic right here, although you're not going to spend the whole class staring at me. Welcome to the class. This is Computer Engineering 180A, and let me share my screen, and then we'll take a look at my slides. Okay. All right. Okay. I'm going to turn off the video, my video. Okay. All right. So you should be able to see a set of PowerPoint slides. Can everybody see that?
Yes.
Okay. Very good. Very good. At any time you have a question, please just unmute and ask, because when I'm in this full screen sharing mode, I cannot see chat messages. And so it would be, if you have a question, just unmute and ask. Okay. All right, let me start out with some basic information about myself. I do office hours every Tuesday and Thursday between 4:30 and 5:30. And of course, we're doing it online via Zoom. I do have an office at the university, but of course, I'm working from home. I have a faculty webpage, which you can see here, and there is a webpage for the class itself, okay? And on that webpage, you'll find the syllabus, the assignments, and I do try to post the lecture notes before each class, unless I forget, in which case somebody, I'm sure, will remind me. Okay, let's take a quick look at the webpage, and we'll go over the syllabus. Okay, looking for...
Professor, I just wanted to ask a quick question.
Yeah.
Are these lectures going to be recorded and uploaded to Canvas? Okay.
Yes, yes. We're recording now, and it takes about an hour or so after each class for the recording to appear, and then maybe a day later, a transcript of the audio shows up. But I'll try to post as soon as I can, whatever Zoom provides. I don't know why it takes so long for the audio transcript, but I guess they have an algorithm for creating those. Okay, so this is my faculty page. And if you click on 180A, okay, let me make this a little bit bigger. You'll see the information about this class, okay? And so, see, I've already posted the first assignment, and I've already posted the slides, and then the various sample programs that I'm making available. Also, the one of the textbooks by Savage. Well, actually, both textbooks have provided slides, and so I will post the appropriate set of slides from the textbook. And so you can get my lecture slides and slides provided by the book publisher. Okay. All right, so let's take a look at what I have here. I've got the goals of the class. It's basically becoming familiar with the C++ language, and then looking at how C++ allows us to implement various data structures and algorithms. Okay, I will spend time up front making sure everybody is familiar with the language. C++ is a very large and complex language, and you know, it doesn't make sense to talk about data structures and algorithms if you don't really know the language itself. So I want to make sure everybody is good at programming in C++. Also, besides being a very large and complex language, quite frankly, it's a somewhat dangerous language to be programming in. There are a number of pitfalls that you can fall into if you're not careful that will cause your program to crash or otherwise go haywire. And I will try to point out some of those pitfalls, try to point out why certain things that certain things take a lot longer than you would imagine. And I'll try to explain why the language behaves the way it behaves. Okay? So we'll be sure to make sure that everybody becomes a good C++ programmer. And then, of course, I'll make sure everybody is familiar with the basic data structures and algorithms. There are a couple of required books. These are books that were chosen by the computer engineering department. You can probably find old editions of these books, and probably that will work out fine. Although I am going to cover some of the newer features of C++. And so if you get a very old edition of these books, then they won't cover these new features. Okay, there is some software that you'll want to explore and install. I tend to do everything inside of Eclipse. Eclipse is a development environment. It has an editor, and it just makes it very nice to develop programs using Eclipse. And I have a link here that will tell you how to download and install this version of Eclipse. Eclipse started out as an integrated development environment for doing Java, and Eclipse itself is a Java program, but there are plugins that enable Eclipse to work with other languages, and Eclipse CDT is Eclipse with the C development tool built in. And so if you are running Eclipse CDT, you can then use it to edit and debug your C++ programs. Okay. Now, I would kind of caution against using, if you're on Windows, there's Microsoft Visual C++. Unfortunately, it's not the industry standard C++, and so you run the risk of writing programs that will only work with Windows, and you don't want that. In your future classes, you'll most likely be using a Linux, and so you don't want to end up writing programs that only run on Windows. Okay. If you're on a Macintosh, you're fine, because the Macintosh operating system is built on top of Unix, which is what Linux is built on top of. So you'll be okay. So what do you do if you're on Windows? Okay, well, Windows 10 has this relatively new feature called Windows Subsystem for Linux, WSL. And by using WSL, you can install Linux to run inside of Windows. And the Linux distribution that I like is Ubuntu. And so if you're on a Windows machine, I would strongly recommend installing Ubuntu and doing all your work inside of the Ubuntu environment. That way you'll be using the Linux compilers, and those are the industry standard compilers. Similar thing on the Macintosh, don't use Xcode, which is Apple's development environment, because then you run the risk of developing programs that will only run on the Macintosh. Okay? Remember, the industry standard is based around Linux, and so you really, really want to be working in that environment in this class. Okay, so I have a couple of tutorials that I've written on how to install the Ubuntu and how to install Eclipse so that you can use it for C++ development. There are other development environments for C++. I'm not familiar with them, but you're welcome to use them. As long as you are writing programs for the industry standard C++ compiler, I don't care how you edit them. Okay, so but I will be using Eclipse in this class, so you're going to see me using that environment. Okay. So each week I will post the assignment for that week, and I also try to remember to post the lecture slides. Okay, so the slides I'll cover today, you can go ahead and download. Let's take a look at the syllabus. Okay, so let's see, we already talked about this up here. Now, besides the official description that you'll find online on the university's at the Computer Engineering Department website, I added a few things. I want to cover some of the modern features of C++, such as lambda expressions, smart pointers, and move semantics. If this sounds like gibberish, by the end of the semester, you'll know what I'm talking about. And as I mentioned, C++ being a somewhat dangerous language because it's so powerful and has so many features, I want to show you how to write efficient programs. I want you to adhere to good design principles, okay? And then, of course, we want to avoid the pitfalls of the language, okay? Course learning outcomes, obviously object-oriented features, some of the advanced features, modern features. We'll talk about the standard abstract data types of the language. There are standard algorithmic techniques, such as sorting and searching and doing recursion. And then, excuse me, on your own, you will probably pick your favorite software development tool, and you're welcome to use whatever development tool, as long as you write programs in the standard dialect of C++, the industry standard. Okay. Academic integrity is very important, something the university as a whole and the computer engineering department emphasizes. In this class, you're welcome to work together. In fact, I remember when I was a student, having little study groups is a great way to learn. But then when you turn in an assignment, you're going to be writing programs, make sure those programs are your own individual work, okay? And there is a program, which I'll show you later, from Stanford University. And the way it works is that when I get all your assignments, I upload them to this server at Stanford, and it uses artificial intelligence to detect whether or not two students may have copied from each other. And it does a comparison of the program, and it's very, very smart in the way it does it. So we'll talk about this later, but basically do your own work, and there won't be any problems. Okay. Back when we still had classrooms that we could go to physically, exams were videotaped. They would set up cameras in front of the classroom. And of course, now everything is online. So of course, I I turn on the Zoom recording. Unless there are changes within the next few weeks, your midterm and your final exam will be done online. And I'll ask you to turn on your cameras while you're taking the exam. Okay. Let's see, required textbooks. These are the ones that the department told me I should be using. There are some books that I found that may be useful. If you can find them in libraries, or if you can find used copies or borrow these books from people, then you're welcome to do that. Bjorn Stroustrup, this person here, is I guess the father of C++. He was one who came up with the idea of this language. And so, of course, he's written the definitive language manual for C++. Okay. There are some books on data structures and algorithms. I've often taught the data structures and algorithms class, and I use the textbook by Mark Weiss. Okay, yeah. And there's a Java version of the textbook and a C++ version of the textbook. Of course, in this class, you would probably be interested in the C++ version. Okay. Okay, so that has to do with books. I already mentioned software that you want to install. I have some tutorials here that may help you. In the class, we're going to concentrate on the 2011 version of C++, and that's not the default. And so when you compile things on the command line, okay, G++ is the name of the compiler. It's called G++ because it's a compiler from an organization called GNU, G-N-U, and so it's G++. And okay, we can see that this is a minus. Okay, I see that Microsoft Word did a correction, and of course it did a bad correction. This dash is really 2 hyphens, and I'll have to try to fix this, and I'll show you later on how to compile something on the command line. Okay, and okay, so oh, and then inside Eclipse, when you are using when you're developing a C++ application in Eclipse, you also have to tell Eclipse to use this version of the compiler, because by default, I think it uses an older version. So I'll show you how to do that. Okay. Now, I expect this class to go pretty quickly, especially in the beginning when I'm just getting everybody up to speed and up to the same level with C++. I know some of you have already programmed in C++, some of you have not, and so I have to kind of get everybody up to at least the same level before we really get into data structures and algorithms. But that part of the class is going to go pretty quickly because there are a lot of tutorials online, and of course if you get these textbooks, you can read the textbooks. This first one by Savage assumes you don't know C++ and you're just starting out, and so it starts at the very beginning. The other one assumes you already know C++ and gets into the data structures and algorithms. Okay, so if you don't know C++, you will need a book like this or find online tutorials. But I'm going to go pretty quickly in the first few weeks. Okay. Each week there will be what I call the main programming assignment, and it will be worth at least 100 points. And then I will also try to have a number of short practice problems, each worth maybe 5 points. Each one as the name implies, gives you practice using a particular feature of the language, like practice using arrays or practice using vectors. And the practice problems will help give you the skills to do the main programming assignment. All the assignments will be in Canvas. Okay, so if you go into Canvas, I believe the main programming assignment for the first week is already up there, and you should be able to download the write-up on it. Okay? This will be a challenging course, especially if you're not already familiar with C++. So expect to spend a lot of time and effort on it. Okay. Exams will be online, and in the past, when I've done online exams, they have been open book. Okay, because obviously, if you're at home, there's really no way I can prevent you from using a book. So I'll just make it open book, and so I'll be testing whether or not you understand concepts as opposed to whether or not you know where to put all the semicolons in the language. Okay, grading. Okay, so as you can see, nearly 2/3 of your grade will be based on the assignments. This is a programming class, and so you should be graded on how well you program. 15% on the midterm and 20% on the final exam. Okay. Now, each exam will be graded, and you'll get a score, from 0 to 100 or whatever the maximum score is. And I won't assign a letter grade to each of the assignments. But at the very end, now this class is going to be is a credit, no credit class. So I grade on the curve, and I will, at the end of the semester, calculate everybody's score. Actually, Canvas will do that for you. Canvas will know about these weights, and as we enter your assignment scores and your exam scores in the Canvas, it will keep a running a total of your weighted score. So at the end of the semester, I will line up all the scores, in increasing order, and I would expect at least 75% of the students will get the credit. Okay, actually, in reality, there have been times when it's been closer to 95%. I mean, if you attempt all the assignments and do well on them, you'll be fine. The students who get no credit generally are students who don't turn in all the assignments. For whatever reason, you end up not turning in assignments. Well, of course, that's going to drastically lower your score. And if it's low enough, then I have to give you the NC. And I don't know what happens if they make you take the class again, or yeah, you don't want to find out. You want to get the credit, okay, the CR. Okay, some Zoom classroom etiquette. This is all boilerplate stuff that we were told to insert into our syllabi. Now, if you need equipment to work from home, a laptop or something, you can borrow them from the university. It does have an extensive loaning program. Now, of course, you have to come to the campus to pick up the equipment. So, if you're far away at home, that may not help you. But you're going to need a decent laptop at least. And for the exams, we ask that you have a camera that you can turn on. Okay? All right, so here is my schedule. And so each week, I'll have some topics that I want to cover, and then I do list what chapters are in the textbook that cover these topics. And so you can see I'm going to zip through the first 3 chapters this evening. Okay, and so we're going to start out with the Savage book, which, as I said, teaches you C++ from the very beginning. It assumes you don't know the language. But then later on, we'll start picking up chapters out of Malloc, and that's the book that assumes you already know C++ and talk mostly about algorithms and data structures. Okay, so you can see how towards the end of the semester, we rely more and more on the Malloc book. Okay. So given that there is so much in the language, and we're going to try to cover so much in this class, there's no way that my lectures can possibly cover everything. And so I will assume that you've done the reading or something equivalent, and my lectures will just try to cover the important highlights. I'll try to cover all the features that you'll need to know in order to do that week's assignment. But there's no way that if you rely completely on my lectures, you're not going to get the full picture. There's just no way I can cover everything in the time that we have. All right, so you can kind of see the progression of topics. We start out, just learning about the language, and then we slowly get more and more into the data structures and algorithms. See, here we're talking about vectors and so forth. And along the way, I will, as I said, point out the pitfalls so that quite often you'll write a program that looks perfectly fine, and when you run it, it crashes. And so we need to learn how to figure out why our programs are crashing. Okay? What can be very frustrating is that you get an assignment to work perfectly well, apparently, on your laptop, and then you paste it into CodeCheck to have CodeCheck run your program, and it will crash inside the CodeCheck. And you'll wonder, well, it doesn't crash on my machine. Why is it crashing on CodeCheck? And normally, or not normally, but quite often, that's because you are trying to access protected memory. Every operating system has certain areas of memory that it does not allow application programs to access. But different operating systems have different areas of protected memory. And so most likely your program, even though it appears to be working, has a subtle bug that's causing it to access memory other than what you expect it to access. And on your machine, it's maybe randomly accessing some memory and you're getting away with it. But when you run it under CodeCheck, that random memory access is getting into protected memory, and the operating system will immediately kill your program. Okay? But it'll be kind of hard to debug because it works on your local machine, but it doesn't work on CodeCheck. So these are the sorts of frustrations you're going to run into, and that's the nature of programming in C++. Getting frustrated. All right. So this is the schedule. I will try to keep to it best I can, but depending on your reactions, I may speed up or slow down. Okay. All right. So that is the syllabus, and again, you can access it from my class webpage. Okay. Now here is, if you click on this link, it'll download the slides. If you click on this link, it'll take you to the first assignment, which we'll talk about later in the class. Okay. All right. All right, so go back to my slide. Any questions so far? I know I can talk a lot, and You know, when classes were live in front of the classroom, I talked very fast, and sometimes that that bothers some students. Now that we're online, I do try to slow down and not talk too fast. Okay? But if you're getting lost, then be sure to speak up, and I'll try to clarify things. Okay? Now, you're going to learn a useful subset of C++, okay? And fundamental data structures and algorithms as you would program them in C++. I will try to emphasize the best practices for developing reliable software, and I will try to give you some software development skills, okay? These are all valued by employers, okay? So I will try my best to help you get hired, okay? Now, what are not course objectives, okay? This is not a class that will teach you complete knowledge of C++. I mean, even if all we did was talk about C++ and not also data structures and algorithms, you would still not be able to cover the entire language, okay? So I'm just going to hit on the most important features, and so will the textbooks, okay? Things that I don't talk about in class, of course, you can get from online tutorials or textbooks. We'll briefly touch upon some of the newest features of the C++ version 11 and version 14, okay? The 11 comes from the year 2011, which is when it became an industry standard. There's a 2014 version that has some new features, and there's also a 2017 version of the language. Okay? In all my classes and in all my work, I have worked with version 11, but we're starting to see some useful features that are being supported by the compilers from version 14. And so I'm going to talk a little bit about some of the new version 14 features. I haven't looked very intensely at version 17, so we're not going to talk about that version. And I'm sure there's a version 20, and you know, the language is constantly evolving. Okay. Now, this is also not a course on advanced data structures and advanced algorithm analysis. I believe there are graduate courses offered by the department if you really want to get into the advanced, very, very advanced stuff. Okay. I will introduce you to algorithm analysis. And of course, you know, we'll cover the basic data structures and algorithms. Okay. All right. In the past, I've taught this class for several semesters. I've arranged for the grader, the ISA, also to have tutoring hours. And so for 1 or 2 hours during the week, the grader will have office hours, and you go into an office and he'll help you with the assignments. Now, of course, we no longer have the opportunity to have somebody working in an office that you can go visit, okay? And I've also been told that, you know, because of COVID-19 and maybe lower enrollments, that there's a budget crunch, and so I cannot guarantee that there'll be enough budget for me to hire people to provide tutoring. Okay, but I'll try. Okay. Now, when the ISA is on board, okay, I've already hired him. I've already hired her. It's a young lady. I will post information so that you can contact the ISA if you have any questions about how your assignment was graded. So I should change the gender to her. I didn't know who I was going to end up hiring when I made these slides. Okay, okay, we already talked about the textbooks. talked about software to install. Okay, when you go to the Eclipse CDT site, you'll see a page that looks like this, and you can, of course, click download, and then there'll be instructions on installing the Eclipse. Okay. But you're welcome to use any other development environment. I am most familiar with Eclipse, so that's what I'll be using in class. As far as the Macintosh is concerned, GNU C++, which is the industry standard C++, is pre-installed on the Macintosh, and it's often pre-installed on any Linux platform, and then so it's already there, you just go ahead and use it. But lately, I have noticed that when you install Ubuntu, such as if you're on a Windows platform and you want to install Ubuntu, the compiler is not included. And some other utilities that are useful for software development are not included. And so if you look at my tutorials, it's very easy to install the development tools. It's basically a couple of commands that you need to type in, and then they get downloaded and installed. So if it turns out that you have a Linux distribution that does not have C++ pre-installed, then you have to go and do that. I already mentioned about avoiding using Xcode and avoid using Visual C++. Okay. Now, before Microsoft invented this Windows subsystem for Linux, in order to get a Linux type environment, I had students downloading something called Cygwin. But you know, now there's no excuse not to use the actual Ubuntu that you can install alongside with Windows. So use the Windows subsystem for Linux and do that installation. Okay? And then I already warned you about using Microsoft's C++ compiler because it's not industry standard. All right. Okay, here's a link to Windows subsystem for Linux. And I happen to like the Ubuntu distribution, but you can use Debian or any other Linux distribution. In fact, Ubuntu is built on top of Debian. So the kind of support that I can give, I can help students that have Macintosh problems with the assignments. I can help students who have Linux problems, but I'm not very good at Windows. And so if you insist on using Windows and you insist on using Microsoft Visual C++ and something goes wrong, I'm not going to be able to help you. Okay, so if you're on Windows, you really, really, really should install Ubuntu and then do your work in the Linux environment. All right. Some useful tutorials, as I said. I wrote these a couple of years ago and I tried to update them, but no guarantees that it's 100% up to date, because obviously these websites that I'm directing you to in the tutorials, they keep changing and I can't keep up with all those changes. Okay. We're going to use the C++ 2011 standard. And okay, so this is the way you're supposed to type it. It's 2 hyphens in a row. And unfortunately, when you do that under Microsoft Word, it says, oh, you really mean a dash. So it does a so-called correction. So make sure it's 2 hyphens that you're typing there. Okay. All right. I will show you this later on when I do my Eclipse demo. of how to make sure that inside Eclipse, you're using the 2011 version of C++, okay? So we'll get to that later on. All right, assignments, okay? When you're learning a new programming language, and I know several of you are learning C++ for the first time, or getting a refresher course in C++, it's practice, practice, practice. That's how you really, really learn a language. So every week there'll be a main assignment, and then maybe 4 practice assignments, each worth 5 points. You're not supposed to spend a whole lot of time on the practice assignments. If you're spending more than, say, 20 minutes or so on a practice assignment, then you probably really are misunderstanding the problem, or maybe you really don't know anything about that feature, and you ought to go and learn about it online. Okay? Now, for the main assignment and for the practice problems, we're going to be using an online tool called CodeCheck. Okay? And what CodeCheck does is that you paste your program into CodeCheck, and often I will give you an outline of a program, and so you'll be pasting your code into my outline, okay? And then you press a submit button, and what CodeCheck will do is run your program and compare its output against a master output that I had previously provided, and it will show you whether or not you match, or if there are parts of the output that don't match. Okay, so then of course you can try to fix the program to get the right output. Okay, now you can submit as many times as you like, and when you're finally satisfied with your program and it's getting the output that you're happy with, there'll be a download button. And when you press that download button, CodeCheck will zip up all your source files and zip up the output and put everything together into a signed package. Okay, and then you will take that signed package. I believe it's just a zip file of some sort, and it's that signed zip file that you will then submit in the Canvas. The grader will then unzip your program and run it, and then be able to give you a score on your program. Okay, so each assignment will have a URL that takes you to the appropriate CodeCheck page. Okay, and so right, and later in the hour when we talk about the assignment, I'll show you more about this. Okay? All right. Okay, and the assignments will always be due the following week, about a half hour before class starts. And so assignment 1 will be due next Tuesday at 5:30 in the afternoon. And then at 6 o'clock when I start the class, I will actually go over my solution, and then, because by then you would have already turned in your solution. So we cannot accept late assignments because obviously if it was late, you would have seen my solution. Okay. All right, so let's see what else is there. Make sure you do individual work. I've already mentioned that. Okay. And so I have a reputation that I'm going to warn you about, in that I am very, very intolerant of cheating. I come from a scientific background, and as a scientist, any scientist who cheats by fudging an experiment or saying something deliberately incorrect in any report, you will be caught, and as a scientist, your reputation will be ruined. So I'm very sensitive to avoiding that from happening. And so students who might catch cheating will be reported. And it's actually a university requirement that if an instructor catches students cheating, that instructor is obligated to report the students. Okay, and for as example, last spring I had a class, a graduate class. There were 50 students in it, and I caught 6 of them cheating during the final exam, and I turned each and every one of them in. And those poor students now have to retake the class. Okay. Fortunately, there are 2 sections of that class, so I don't have to see them again this semester. Okay. So you know, I'm giving you fair warning. I do not tolerate cheating. Okay. Now, in order to help prevent cheating, I mentioned this Stanford program called MOS. And you can go ahead and read up about MOS. And I want to see, I do have an example. I don't remember checking this last night to make sure it's still up and running, but okay, it's still there. Okay, so these are actually, these are real examples. Caught a couple of students copying from each other. And so, as I said, when you've all submitted your assignments, I will then collect them all and upload them to the MOS server at Stanford. And then the MOS server will then give me a report that says, hey, look at this. There are programs that match at a very high percentage. So it's saying that between these 2 programs, 92 and 93% of the code appears to be the same. And here it looks like it's 85 and 87. So then that tells me to look at the programs, because I'm not relying 100% on MOS. You know, we're not that far along yet. But okay, so if I click on them, you can see that it displays the code side by side. And through the color coding, it says, boy, this code looks very, very, very similar. Now you notice that the code may have been reformatted. Maybe they changed the names of functions, but you know, MOS is smart enough to see past that. And sometimes students will even change the order of the functions that they have in their program, but MOS will catch that too. So here we see a function in green, and here, and it's followed by a function that's in red, but in the other one, it's the red function first and then the green function, and still MOS caught that. And if you look at the red, which is easier to see, you'll see that, okay, they cleverly renamed the variables, okay, but you can see that the code is essentially the same, okay, and certainly MOS catches that, okay, and okay, we can also compare the green code, okay, so you can reformat the code, you can change the order of the functions, you can change the names of the variables, but MOS does a structural comparison, and it can detect whether or not 2 programs are very similar. Now let's take a quick look at the other one, the other pair. Okay, so similar things. Okay. You can see that, again, the students tried to hide the fact by renaming things, and that didn't work. Okay, so I hope to put a big scare in you that, oh man, I better not cheat in this class, because Professor Mac is going to turn us in, and boy, the penalties are pretty severe. You get put on academic probation. You no longer are qualified to become a TA at the university, and the university may no longer sponsor you for internships or OPT. And you know, I know many students come to San Jose State because we have a very extensive internship programs. And here we are in the middle of Silicon Valley, and students, you know, come from middle of India or middle of China and end up working at Google or Facebook or any of these, you know, well-known Silicon Valley companies. And so I know that's a major, major draw for students to enroll at San Jose State. So you don't want to lose that privilege, okay? I will also mention that I have a major grant from NASA. I used to work at NASA. I was a senior scientist there. So I have a major grant from NASA that allows me to hire students to work as interns at NASA. And so you want to be really nice to me because I can possibly help you get internships at NASA. Now, currently, NASA is on lockdown like everybody else, and so the hiring is really slowed down, but hopefully that situation will pass, will become past. Okay, so academic integrity, MOS, exams. For the time being, they'll be conducted online and they'll be open book. And of course, once again, don't share answers. The students whom I caught last semester were sharing answers using Dropboxes, and I detected, well, all 6 of them were copying from each other, and they admitted it, and they all got turned in. So all right. Officially, there's no makeup exam for the midterm, so make sure you can take the midterm, unless there's some sort of, you know, medical or family emergency. And then for final exams, there is a makeup for final exams. So if it turns out that maybe you have too many exams final exams on the same day, you can arrange with your instructors to move one or more of the exams to a makeup day. Okay, so that's something, of course, you have to notify me in advance. Okay? And then we already talked about how I will weight your total score. Canvas knows about these weights, and so you can keep track of your score inside of Canvas. Canvas will also tell you, I believe, what the average score is. But if you're in the top, you know, 75, I mean, unless you're in the bottom 25%, you don't have to worry about not passing. And as I said, there have been some semesters where I've passed maybe 95% of the class. Let's see. Okay, here I say I expect 80% of the students will pass. I think I said 75% earlier. And as I've said, I've gone as high as 95%. If you don't skip assignments and you make an honest attempt on each assignment, you'll be okay. All right, I'm going to take roll, and the way I'm going to do that is I'm going to have Zoom display to me the list of students who are logged in, and I've been told that for privacy purposes, I'm not supposed to display this list to the class. So I'm going to stop sharing, and then I'm going to then put up the list and take screenshots of it. So that's how I'm going to take roll. All right, so I appear to have lost, oh, there's my mouse. Okay, so I'm going to stop sharing. Okay, so you should no longer see my screen. And so I'm going to bring up the list of participants. There are 51 of you, so there's no way I can get this all in one shot. So I'm going to have to end up taking several screenshots, you know, take a shot, scroll, take another shot, scroll, and so forth. So here we go. There's one. Let's see. Okay. Hang on. All right, I just have to scroll once. I'll take another shot. And just like in real photography, I'm going to do it again to make sure. This sure beats me reading off people's names and mispronouncing them. Because that you know, with so many students, that would waste like 20 minutes. And here I'm going to do it all in about 2 minutes. Okay, one more. I see I have several guests. Wow, quite a number of guests. I suspect you're checking out the class to see if it's worth enrolling. All right, I think I've gotten everybody. Turn off the list. Oh, I see 2 people have sent me chat messages. Okay, can you repeat about assignment submission and what is the assignment format? If you look at the assignment write-up, which we'll take a look at later, you'll learn that inside of CoCheck, when you're satisfied with the output, like it matches with the master output or whatever, there is a download button. And when you click the download button, it packages up your program, you know, the source code, along with the output, packages it up into a signed zip file, which you then which you'll download, and that's what you turn into. That's what you submit into Canvas. Okay, so we'll go over that when I talk more about the assignment. Okay, but it's really a pretty straightforward process. Okay, it's not too bad. All right, I'm going to share the screen again. And so,
is taking roll going to be a weekly thing, or?
No, you know, for classes that meet twice a week, they say that I need to take roll during the first 2 classes, and so I guess I may do this again next week. But then after the first 2 classes, I don't take roll. And the way the rule works is that if a student does not show up during both times I take roll and hasn't provided an excuse, then I can manually drop that student. So that's why we take roll. Okay. All right. Okay, fast pace, as I mentioned, I know from student surveys that with these online classes, students hate it when it's just one PowerPoint slide after another. Now I do create these PowerPoint slides, and of course, you know, back in class, I could interact with the students more. A little bit harder to do now, but as I said, if you have any questions, just unmute and speak up. Okay. I will post the slides and any example programs. Okay. And I already showed you the class webpage. Okay. There is a discussions feature of Canvas, and so if you have any questions, unless it's a personal thing, then I encourage you to ask the question inside of the discussions feature, because that way, if other students have the same question, I only have to answer it once. And quite often, other students will answer the question before I get to it, and that works out really, really well. Okay, that's the discussion feature of Canvas. Okay, all right. Any questions so far before we finally get into our subject? All right. Question is, what is C++? It's an object-oriented.
So, sorry, I have one quick question.
Yeah.
Just regarding the role, I went to the bathroom like 10 minutes ago and I just came back. And when I came back, the slide you were on was the role slide. Did you already take it? Because I think I might have missed it.
Well, as long as you were still logged in, I basically took screenshots of whoever's logged into Zoom. So unless you logged out when you went to the bathroom, I would have gotten you.
Oh, yeah, I left and then I rejoined.
Okay. Well, send me an email then.
Okay.
And I'll make sure that your account.
Excuse me, Dr. Mark.
Yeah?
It took me 30 minutes to find the link to the Zoom. I assume I could sign into the Zoom session by the office hours. It didn't work, and I signed in a little late because I had problems to find the link.
Oh,
Did you go over the attendance at the beginning?
I took roll about 10 minutes ago or 5 minutes ago. So if you were logged in at that time, I would have gotten you. But to be sure, why don't you send me an email, and then I'll make
Thank
sure
you.
you're counted. Yeah, I see
Great.
now we have 53 participants. I think there were 51 when I took roll. So
Oh,
2 more people
you-
joined. Okay,
Thank
so
you.
any other questions? All right, so what is C++? It's an object-oriented programming language. It supports encapsulation, inheritance, and polymorphism, which are the main characteristics of object-oriented programming. It was based on the old C language, and they added on object-oriented programming features. As I mentioned earlier, very powerful language, but very complex, lots and lots and lots of features. Somewhat arcane syntax, and the reason is because it's the C language had kind of an arcane syntax, and because C++ is built on top of C, it inherited that syntax. And so you're going to find that, to specify certain things, you have to do things in kind of an odd way. It's easy to make programming errors. And then another feature of the language is that at one time when you're running your program, it does things behind your back that you may not realize. And so in most programming languages, you write the program, and by looking at the program, you can pretty much figure out what's going to happen at runtime. Okay? That's not necessarily true with C++, because, okay, you write your program, but as your program is running, it's doing other things behind your back related to your program. And if you don't know that it's doing these things, then you might end up with a program that doesn't work the way you expect. Okay, so that's some of the things that I'm going to make sure we learn to watch out for. Okay? Now, I'm going to try to teach you a useful subset of C++. Okay? Very few people, not including me, know the entire language. I definitely do not know the entire language. Among professional C++ programmers, you're going to discover that if you talk to different professional programmers, each person knows a different subset of the language. And it depends on the person's experience, the training, what application domain that person's working in. And so, of course, there's going to be a lot of overlap, but it's going to be very rare that you're going to find somebody who can legitimately claim to be an expert in the entire language. Okay? And I'm definitely not that person. If you ask me a question about something, I'm more than willing to say, I don't know. Why don't you look it up? And maybe in a discussions feature, tell us what you discovered. Okay? But I will make sure you know a very useful subset of the language. Okay. All right. Now, quite often, you're going to ask yourself, what happened? Why did my program behave differently from the way I expected? Why is it running slower than I expect? Why did it crash? Okay. And that's often something that we'll have to figure out together. Either we'll do it in class, or send me the program and I'll try to look at it, or we'll meet during my office hour and we'll look at it together. You may have stumbled onto some obscure language feature, and that's causing your program to behave differently. Okay, and then I already mentioned this problem that you will use your Eclipse or whatever your favorite development environment is on your personal machine. You get the program to work fine, and then you say, okay, now I'm ready to submit it into CodeCheck. You paste your program into CodeCheck, and CodeCheck says your program crashed. As I mentioned earlier, this is often due to your program trying to access protected memory. Now, C++ has pointers, just like the C language did. And the pointers, basically, you get to play with machine addresses. And of course, if you mess up a pointer, you may end up trying to access memory in an area the operating system does not allow. The operating system that you have on your machine and the operating system that CodeCheck is running under may be different. And so, you may have gotten away with a bad pointer on your machine, but you got caught by CodeCheck. Okay, so as I said, you're going to have to endure some frustrations, and that's just the way it is. All right, here's your very first the first C++ program I'm going to show in class. And of course, is the infamous Hello World program. Okay? And you run this program, and it writes out Hello World. Okay? So on the command line, this is what it's going to look like. And I'm going to actually do it on the command line. The compiler is called G++, not C++, but G++. And this file here is helloworld.cpp. .cpp stands for C++, so that's the standard suffix for a C++ source file. Okay, we're going to run the standard, the version 11 version of the compiler. So we're going to say --std equals C++11. And when the compiler compiles this program, we want the object, the executable file, to be named Hello World. And -O stands for object file, or the output of the compiler. Okay? Now, after we successfully compiled, and we have indeed the executable file called Hello World, here's how we run it. Okay? You have to say /Hello World. Okay? Hello World will be in the same directory as helloworld.cpp. And if you want to run a program that is residing in the current directory, then you have to say /. Hopefully, it will say Hello World. Okay? So let's try that. Okay. So I'm going to go out to the terminal window. Okay. All right. So what you're seeing here is from my compiler class. So let me go to the directory that contains the Hello World program. And you see here, on here, and this is 1A, and we're going to be looking at the programs. And you see, there's going to be a lot of programs that we're going to look at as examples here. There is Hello World, and I'm going to go into that directory. So cd to Hello World. Okay. So now I'm in the Hello World directory. Let me actually delete this. This is the executable, and I want to actually create the executable before your very eyes. So I want to delete the one that's already there. All right, so we're going to do, okay, what happened to the terminal window? I've got too many things open here. So we're going to then type in this command. Okay, so, well, first of all, let me clear. And I want you to see that helloworld.cpp is here. Helloworld.cpp. And there it is. I hope you're all familiar with Linux command line. Okay, so I'm just going to assume that you know what cat is. And okay, now here we go. G++ hello world.cpp --std equals C++11. I'm going to output -o to be hello world. Okay, and it's going to compile it. Okay, I don't know why it's taking this long. Okay, there it goes. And now, yes.
Would you please briefly say what cat means in Linux, because I'm not familiar with Linux.
Okay, so you should then find a tutorial online of the Linux command command line. And so cat is short for catenate. It basically is a command that prints out the contents of a text file. And here I'm now typing a command to invoke the G++ compiler with these various command line options. The name of the source file, and specifying that I want to use the 2011 version of the compiler, and I want the object file to be called hello world. And now that there should be that object file, and I should be able to run it. There goes hello world. Okay. Now just to demonstrate that you don't have to call it hello world. Now one of the features of the command line is that by using the arrow keys, you can go back to earlier commands, and then you can then edit them. So I'm going to change hello world to just H. Right. And so now I should be able to, not only do I have hello world, I should have executable file named H. Okay. So that's what it looks like when we compile on the command line. Now, what does it look like when you're inside something like Eclipse? Okay, so here I brought up Eclipse. And let me put away the terminal window so we don't have too many things cluttering up the screen. Okay, put away Moss. Okay. I hope Moss has scared all of you. I'd rather you be scared than be cheaters. Okay. All right, so here's the program again. And so you can see this is an editing window. I can edit here. And then now when you're inside Eclipse, you create what are known as projects. So this is the Hello World project, and one of the files in that project is this hello world.cpp. Okay. Now by clicking on the project name and bringing up with right-clicking on the project name, you can bring up properties. Okay, so here I brought up the properties of this project. And one of the properties you want is under C++ build, there's settings. And then under settings, under the C++ compiler, there's dialect. And here, under dialect, you can choose what dialect you want. Okay, and of course, we want the C++11 dialect. Now, if you don't choose a dialect, I think it defaults to the 1998 version of C++, which will not have some of the features that we want. I can see I've talked too much already. So you want to make sure that you choose C++11. All right, so I'm applying close. Okay, and now I click the hammer, which compiles the program. So, okay, there you can see it wrote out the command line that it used. Now I notice here that it only used one hyphen for the standard, whereas I use two hyphens. Evidently, it works both ways, but let me check to make sure what is considered the official way of doing it, and I'll let you know. Okay. As I said, I use 2 hyphens here, but it looks like Eclipse only put in 1 hyphen. Okay. As I said, there are so many details of C++ that it's really hard for me to keep track of all of them, especially since I also teach classes in Java and Python. It's just a little too much. Okay. All right. So now that I've compiled it, I can run it. And one thing you'll learn is to create these run configurations. So now I'm ready to run Hello World. And it's going to run. There it is. It writes out Hello World. Okay, so this is what it looks like when you do it in Eclipse. Okay. All right. But you can choose whatever development environment you like. Okay, so there we go. We've gotten Hello World out of the way. And I will definitely look into this 1 or 2 hyphen business. But in any case, it's a hyphen and not the dash character. If you put in the dash character, it will not work. Okay, that I know for sure, because I've accidentally done that a few times. Okay. All right, so there we go. Okay. Right. Now, as I mentioned, I will provide slides that the publisher of the Savage book has provided. And in the slides, there are other sample programs, and I will point them out because you may want to look at them. And for some reason, the slides are called, instead of figure 1.4, it's display 1.4. But when you look through these slides, you'll find these examples. All right, and then there's another sample C++ program. I guess there are 2 of them. One of them is called a sample C++ program. It may be Hello World, I don't remember. And then there's a slightly more significant program called Peas and Pods, or Pods and Peas. Okay, so you can look at them as examples of simple C++ programs. Okay. All right, any questions so far? All right, identifiers and variables. Okay, just to make sure everybody is on the same page. Identifiers are names, okay, and variables are names that represent values that can change. So variables have names. They're called variable identifiers. Okay? And when you write a program, you have to do something called declaring a variable before you use that variable. You have to declare all your variables. And a variable declaration tells the compiler certain information about the variable, namely the name. So here we have variables named n, ratio, and is prime, and so forth, and also its data type. So n is an integer variable, in C++ is called int. Ratio is what's known as a floating point variable. So it's a real number as opposed to an integer number. And double says that we want to use what's known as double precision. Okay? This will all become clearer later. If this sounds like gibberish to you, then hopefully tutorials or the book will explain it. But when you have what's known as a floating point number, it's a number that's not an integer, it has a fraction. You can specify or control how many digits you want after the decimal point. And double is a double precision number, and you get about 16 digits after the decimal point. A float, you get about 8. Okay, that's why it's called double, because you get double the number of digits. And that depends, that determines how precise your numbers are. Now, 16 places out, 16 significant digits, that's pretty precise. And that's probably more than enough for most calculations. In fact, your first assignment will be to do some double precision calculations. Okay? A bool is a variable that's either true or false. Okay? And quite often we give it a descriptive name like, is this prime? And this variable will be either true or false. Okay? Char is a variable that has a single character as its value, and a string, of course, well, here's an example of a string. It's a variable that can contain a string of characters. Okay? So these are declarations. Now, when you declare a variable, you can also initialize it to its initial value. And so here are some more declarations where not only have we declared the variable, we've also given each variable an initial value. Okay. All right, so those are variables, and that's how we declare them. Okay. Now, there are certain keywords that are reserved by C++. Therefore, you should not use them as variable names. And here are examples: if, for, and while. So, and there's a whole slew of these keywords, and you can look them up online. And you just have to know to avoid using them as variable names, because you will get the compiler very, very confused if you try to use for as a variable name, and it thinks you're trying to write a for statement. Okay. C++ is case sensitive, so all the keywords are in lowercase. And if you have variables, okay, ratio written all in lowercase and ratio written with uppercase R, those are two different variables. Okay, so you really want to avoid distinguishing different variables simply by their case. Okay, that's a bad programming practice. I mean, you can have ratio with all lowercase letters, ratio with a capital T, and that will be a different variable. Okay, even though you can do that, you should not. Okay. All right. So keywords. Okay. Assignment statements. Okay. Now I already showed you that you can initialize a variable when you're declaring it. So here I've declared a variable I to be an integer, and I'm giving it 5 as its initial value. Now later on in your program, of course, you may want to change the value of the variable, and then you would just use an assignment statement. Okay, and say here, after I've declared I to be an integer and given it an initial value, later on in the program, I'm going to say, okay, now I want I to have the value 10. So this is known as an assignment statement. Okay. Now you may have already noticed that statements in C++ end with a semicolon. Okay, so be sure you don't leave off the semicolon. Okay. All right, now here I'm going to show you some of the things that will drive you crazy. There is the equal sign for doing assignments and for doing initializing variables, and then there's the equals symbol. Okay, so each of these, this is one symbol, and this is one symbol made up of 2 characters, and the single equals is for assigning values, and the double equals is for testing equality. So here, this if statement is testing whether or not I is equal to 10. And then, of course, this will be either true or false, whether or not I is equal to 10. So a very, very common programming error is inside an if statement, you meant to say I equals 10, and you said I equals 10 by mistake. And it turns out that that will work. I mean, it is syntactically correct, but of course your program is not going to work the way you expect it to work, and it may be very hard for you to spot this error. Okay, I think some of the newer compilers will actually warn you if you do a single equals inside an if statement, it'll put out a little warning that says, hey, did you really mean equals or equals equals? But some of the older compilers just let it go by, and then your program doesn't work, and you wonder why your program doesn't work, and you spend all night looking for the bug before you spot it. All right, let's take a break because I've talked way too much already. How about a 15-minute break? But before we break, any questions so far? Am I talking too fast, talking too slow? You've already fallen asleep? Whatever, okay? All right, so if there are no questions, then I will mute the mic so you don't have to listen to my cats, which are laying down next to me. And then we'll come back in 15 minutes. So let me just type a time here. How about 7:40? Is that a good time? Okay. 7:40. Okay, so we'll break until then. All right, so I guess I will stop the recording so that you don't get a recording with 15 minutes of dead air. And see, how do I stop the recording? Well, I'll mute and I'll figure out how to stop the recording. Okay, is everybody back? So I want to talk about input and output. Okay, obviously you want your program to be able to write out results, and you may want your program to be able to read in data. Okay, now C++ likes to think of input and output, or I/O, as a stream of characters. Okay, so an output stream is your program writing out characters or any form of output to some device. And input stream is your program reading in characters from some device. Okay, so there are, let me close the window here. There's a lot of barking. Okay, so there are two standard streams. One called cout. Okay, it's basically by default is the display. So when your program writes out something, it shows up in your display. Okay. Now, of course, later on you'll learn how to write to a file and to other devices, but by the default cout writes to the display. I think the C stands for console, and so this is like console output. All right, so here's how we do it. Okay, we want to write out the string x equals followed by blank followed by the value of x. Okay, and see here's cout, and notice these red symbols here. Okay, so basically it says you're streaming into cout. Okay, so this is actually known as the insertion operator. I just want to call it the write operator because you're writing to cout. That's why the arrow's pointing towards cout. Okay, and this statement will then write out the string x equals blank followed by the current value of variable x, and then this end L stands for end line. It basically is a line feed or a carriage return. And so the next time you do cout will be on the next line. Okay? If you leave off the end L, then the next time you do cout, it will then come right after on the same line of where you left off. Okay, so NL means end of line. Okay, all right, so that's how you write output. Okay, and okay, this is the insertion operator, which I always just call it the output operator or the write operator. Okay, it's called insertion operator because you're inserting the stream of characters into CL. Okay, now when you write out numbers, you want to be able to specify, you know, should it be written in fixed point notation, meaning you want a decimal point in the number with a fixed number of places afterward, or do you want it in scientific notation, which I'm sure if you programmed in many languages, is basically an exponential. There's a big E or a small e, and that stands for a power of 10. Okay, so, but let's just take a look at fixed for now. And then you want to be able to specify, well, how many places after the decimal point do you want? And that's the precision. Okay, so to specify whether you want fixed notation or exponential, you say cout dot set f, and then, okay, it's iOS : fixed. Okay, I know this looks like gibberish, but just believe me, that's what you have to say. Okay, and the key thing is the fixed. Okay, now if you want to specify how many digits of precision, then you call cout dot precision, and here I'm saying I want 2 places after the decimal point. Okay, now this is kind of a cumbersome way of doing it because these are individual statements. Okay, remember every statement ends with a semicolon. Another way to do it is this way. Okay, so here, first of all, whenever we use cout, we have to include IO stream, and we have to include IO manip in order to do what I'm about to show you to do. Okay, so here we have a cout, and we're sending the IO manipulator fixed to it, and we're sending a set precision to it of 16. So here, what I'm basically saying is that when I write a number, I want it to be in fixed point notation and have 16 digits after the decimal point. Now, did I talk about pound include? I'm just wondering if I may have somehow skipped a slide, because I thought I had a slide that explains what that pound include means, and it may have been, what was it, back when I did the Hello World? Okay, just a second here. Here's first program. Okay, well, maybe I explained the pound include later. I thought I had a slide that explained that. Okay. Oh, I do. It's coming up. All right. Sorry about that. All right. So, so for now, just believe me that if in your program you decide to set fixed point notation and output precision this way, okay, well, you always have to include IO stream if you're doing cout or cin, and if you're going to be doing this fixed and set precision, then you have to include IO manip. Okay, and we'll talk about includes in just a few minutes. Okay. All right. How about input, reading in? Well, if there's cout, then of course it has to be cin, and by default, again, talking about the console, so the default is the keyboard. Okay, so if you want to read something from the keyboard that you type, then you use cin. And now notice the arrows go the other way. okay? Because here, this is saying that you want to read the next two values from the keyboard and assign those values to variables x and y respectively, okay? So basically, you're saying that the input stream is going from the keyboard into variable x and into variable y. Okay, so I guess that's the best intuitive explanation I can come up with. And yes, indeed, a common programming error is to get the arrows going in the wrong direction. So, you know, for output, you have the arrows going the other way, and for input, you've got the arrows going the wrong way. And of course, that will make your program not work. Okay. All right. So this is called the extraction operator. And remember, the other one was called the insertion operator. Whoops. Insertion operator. And this one is called the extraction operator. And that's because you're extracting values from Cin and storing them into whatever variables you've got listed here. Okay. All right. And okay, there it is, extraction operator. Okay. So that's how you will read from the keyboard. Okay. Now, if you're going to read two values like this, x and y, then if you're typing them, you would separate the values by one or more spaces. Okay, let's say you're reading in three values into these three variables. Okay, and you're typing on the keyboard. First of all, you would separate the values that you're reading in by one or more spaces. Okay, so maybe this first value is 3.14, and you put at least one space, and then maybe -12. Put another space and 0.005 or whatever, okay? That you would separate in the input that you're typing, separate values by spaces, okay? And then it turns out that your program doesn't actually read the values until you press the return key. So here, if you're going to execute this statement and you want to read in three values and you're typing the three values on the keyboard, you type the first value space, second value space, third value space, and until you hit the return key, the computer doesn't actually read the values. Therefore, before you press the return key, you can back up and make corrections. Okay, so get it right before you hit the return key, and then your program will read in the values. Okay. All right, so that's input from Cin. Okay. All right, let's talk about those includes. Okay. Now, when you have C++ compiler installed, okay, it comes with a lot of code that you can include into your program. So you don't have to write that code because you're pulling it out of a library and you're saying, I want to include that into my program. So earlier on, you saw me including IOStream, okay? Well, remember, I said that C++ considers input and output to be a stream of characters. Well, somebody had to write the code to make that work. And this is the code that you're including. Actually, you're only including the header files, but we'll not make that distinction yet. Okay? And then the code to allow you to say fixed and set precision here is included in a library called IO_manip for input-output manipulation. And so you have to include that. Otherwise, your program will not know how to do cout or any of this other stuff until you include it. Okay. All right, so that's what the #include is for. And notice that you do say # here and then angle brackets. That's just the way C++ does it. Okay. All right, so okay. And then you also have to say using namespace, okay? Okay. Now, just because you've included the definitions of C in and C out when you do include IOStream, okay, well, the names C in and C out are defined in what's known as a namespace, okay? And STD is the standard namespace, and that's where C in and C out and other names that you'll be using later, that's where they reside. And so you have to tell the program that, hey, I'm going to use the standard namespace. Okay? All right, so if we go back to my Hello World program, I think I had, okay, so you can see here I am including IOStream. Okay, I'm not doing anything with fixed or precision, so I don't need to include IOmanip. And here I am saying I'm using the standard namespace so that it knows what cout is. Okay? If you leave that off, then the compiler is going to say, well, what's this cout? Okay, what is that name? Okay. And so you have to do two things. You have to do the include, and you have to do the namespace. Okay. And after a while, this becomes automatic that you start your program with a bunch of includes.
Excuse me, Professor?
Yeah, yes.
Would it be possible to increase the font size?
Oh, this is hard to see on your screen. I can. Okay, hang on. Let me try that. Yeah, I forget that I have a very high resolution monitor, and I can get away with a fairly small font size. Let me figure out how to do it, and then hopefully in the next class it'll be a bigger font. Okay, I don't want to spend time trying to figure it out. Eclipse is itself a fairly complex application, and there are all kinds of menus and property sheets, and I'll never remember where to change the font size, but I'll definitely remember to do that. Okay. All right, so that's what include and namespace are all about. Okay. All right. All right, so
Professor,
yes.
I have a question about the include IOStream parts. If I'm using Windows 10, should that be changed or stay the same?
Okay, so if you're using Windows 10, despite my warnings, I'm pretty sure it's the same includes. Okay, so give it a try. If it doesn't work, then you're going to have to go online and figure out why it doesn't work, because I won't know. Okay. Now, if you're on Windows 10 and you're running inside Ubuntu, then everything that I'm showing here should work. Okay. But I can't guarantee that if you're using Visual C++, which is Microsoft's version of C++, that the same thing will work. Okay. All right. So let me move on. Okay. So some basic data types. So a data type, I tend to write it as one word, but sometimes you can see it as two words. It determines, when you specify the data type of a variable, it says, well, what kinds of values can that variable have, and what operations are allowed. Okay? So for instance, if I declare a variable n to be integer, that means when I run the program, it can have integer values, 3, -2, 5, and so forth. If I declare a variable x to be of type double, then it can have real values like 3.14 and so forth. Okay. Now, of course, by declaring variables to be integer or real or double, then that means I can do certain operations on those values. I can add them, subtract them, multiply them, and so forth. So a data type not only determines for a variable what values it can have when you run the program, it also says what operations you can perform on those values. Now, if I declare a variable s to be a string, and I assign the string hello world to it, then obviously you can't use the division operator or the multiplication operator on a string. Okay. Now you can do other things with a string, like concatenate strings and get the length of a string and so forth. So those are operations that make sense with the string data type. Now it doesn't make sense to ask for the length of a number. So, so when you have a data type, that tells you what values that variable can have and what operations are allowed on those values. Okay. All right, so int is for integer values without decimal points. Now there are other data types. They're short for small integer values or long for very large integer values. Now the reason you would worry about short and long is that maybe you have a huge array of integers and you don't want to use up a lot of memory, but you know that the values are going to be small integers, then you would declare them to be short, okay? Or maybe you have some integer variables and you know they're going to have very, very large values beyond what int can handle, then you make them long, okay? Usually we'll just say int, and you'll see when it's appropriate to say short or long, okay? I rarely use short. I use int and long in my programming, okay? Double for real numbers. Okay, so you hear examples of real numbers. Well, here are some numbers in this scientific notation. So this is actually 3.67 times 10 to the 17th power. And this is times 10 to the minus 6 power, okay? And so you can use either little e or big E. And the exponent, of course, can itself have a plus or minus sign, okay? Now with a double, you will get 16 digits of precision. So that means you can have 16, I'm going to say significant digits, but that may not make sense. I guess another way of saying that is that if you have a number like this, 3 point something, you can have 16 digits after the decimal point. Okay, I know some of you are cringing that I'm saying it that way, but that's the simplest way I can think of. And then there's also float, okay, which gives you only 8 digits of precision. Okay, now depending on what kinds of calculations you're doing, you may have to get very, very precise, so you want all 16 digits, but in other cases, you can get away with less precision, and so you would use float. Now, of course, a double number will take up more memory, and that becomes important if you have a big array of these numbers and you have limited memory. Okay? And then there's char, okay? And if you have a variable declared to be of type char, its values are single characters, okay? And in C++, when you write out a single character value, you surround it with single quotes, okay? And these are straight quotes. You gotta be careful because some editors allow you to have these fancy quotes that, you know, lean one way or the other. Make sure these are the straight, plain old up and down quotes. Okay. Bool, if you have a variable of type bool, and I don't know why C++ didn't spell it all out, but it's bool, then it can have just 2 values. Each variable can be either true or false. Okay. And I'll just point out that internally, inside the machine, a false value is stored as 0 and a true value is stored as a 1. But you really don't need to know that. Just a bool variable is either true or false. Okay. CIN, okay. So when we use the extraction operator or the input operator to read in values, I mentioned that the values should be separated by 1 or more blanks. So let's say that ch1 and ch2 are both char variables, and here's the input, a, maybe at least one blank b. Then when we execute this statement, ch1 will get the value character a, and ch2 will get the value character b. Okay? And if we are reading in numeric values, then in the input, you would then separate the numbers by one or more blanks. Okay. So, all right, so CIN uses blanks or line feeds. A line feed is treated as a blank. So we could have written A and B on two separate lines, and this would still have worked, okay? All right, so that's one thing to know. Okay, now there's the string data type. And so here's an example of a string constant. And again, make sure you use the straight up and down double quotes and not the fancy ones that lean one way or the other. Okay, they are separate characters, and C++ only recognizes the straight up and down quotes. Okay, now if you're going to have strings in your program, string variables or whatever, you need to include string. Okay, and again, you have the angle quotes here. Okay, now if you're going to read strings, like let's say that you have two string variables and you want to read in the string hello into one variable and world into the second variable, then you would type hello and then one or more spaces world, but without the quotes, okay, in the input. Okay, but sometimes you want to read in a string and include the blanks, and then there is a getLine function, and you pass it CIN and the name of the string, and it will read in an entire line, including the blanks, and store that into the string variable. Okay? This is all explained in the chapters of the book. Again, I'm just sort of hitting the highlights. All right, well, let's see. Type compatibility and conversions, okay. This statement is invalid. Why? Because we've said that pi is an integer variable, and we're trying to assign to it a number that is not an integer. This is actually a double. Okay, and so this is invalid. You cannot assign a double value to an integer variable. Okay, so make sure that when you're assigning values to variables, that you are that you're keeping track of the data types. So in this case, this is not allowed in C++. Okay. Now there are some valid conversions. Okay. If you have a double variable, you can assign an int value to it, and it will convert the int value to a double value. You can assign a char to an int to a char, a bool to an int, and int to a bool. So there are some valid conversions that you can do with assignment statements, but going from double to int is not allowed. Okay? You don't have to memorize this. If you do something that is not allowed, the compiler will tell you that it's not allowed, and then you can correct it. I try very hard not to do these conversions. That if I'm an integer variable, then I'm only going to assign integer values to it, and so forth. Okay? But sometimes you may need to do a conversion. Okay? All right. I already mentioned that. Okay. All right. There are various arithmetic operators. This is addition, subtraction, multiplication, division, and this is a modulo to get the remainder. So now Division is a little bit tricky because if both operands are integer, then you only get, oh gosh, what did I say? Yeah, you only get the whole number part of the result. So 11 divided by 3 is going to be 3, not 3.67 or whatever it actually is, okay? So if the both operands are integer, then you only get the whole number part of the result. Now, if one or both of them is a double, you know, like 11.0, then you will get a double result that will have a fraction part, a decimal part. Okay. This is the modulo operator. It only works with integers, and it basically gives you the remainder of a division. So here, 11 divided by 3 is 3 with the remainder of 2, and the answer to 11 mod 3 is 2, okay? And I already mentioned that for slash, if either or both operands are double, then you will get a double result, okay? Again, this is all described in the books, and after a while, you'll just get used to this. Maybe you may find this kind of weird, but many programming languages work this way. Okay. All right, here are some shorthand. Okay. Quite often, you want to add or subtract a value to a variable. So here I have n has some value. I want to add 5 to it and then make that the new value of n. Here I'm subtracting 5 from n and making that the new value of n. Okay? Or I want to take the existing value of n, multiply it by 5, and make that the new value of n, or divide it by 5, or make the remainder. Okay? And then make that the new value of n. Okay? So whenever you see variable equals the same variable plus some arithmetic operation plus another value, okay, here is the shorthand. So instead of saying n gets the value n plus 5, you can say n plus equals 5, or n minus equals 5. Okay? So you're going to see this, and this is something that C++ inherited from the old C language. Okay? And I mentioned that the C language had a somewhat arcane syntax, and C++ inherits that. You don't have to do this. You don't have to do this if you don't want, but this is very common. And even if you don't do it, you're going to see other people doing it, okay, when you read their programs. Okay? All right, let's take a look at the if statement. Okay, so you have if, and then some Boolean expression that returns either true or false. Okay, so if n is less than or equal to 0, then you want to write out this message. Okay, so that's an example of what's known as a conditional statement. Okay, you evaluate some Boolean expression, and depending on whether the result is true or false, you do one thing or the other. Now here, it says if this is true, that n is less than or equal to 0, then you want to write out this message. If it's not true, meaning n is equal to 0, or meaning n is greater than 0, then you do not execute this statement. Okay? So that's how an if statement works. Now an if statement can also have an else part. Okay? Now you're saying what to do both when the expression is true and when it's false. Okay? So here it says if ours is greater than 40, then you want to execute this statement. Else you execute this statement. Okay, so if ours greater than 40 is true, you execute this statement. Okay, and if it's false, you execute this statement. Okay, and the fact that we have these braces here means that you can actually have more than one statement in here, and they'll all be executed one after the other if this expression is true. And same thing down here. You can have one or more statements down here, which are then executed if the Boolean expression is false. Okay, so that's an if-else statement. Okay? We can have while loops. Okay, so here, this says that this is a loop. We're going to execute these statements over and over and over again as long as this expression is true. Okay, so while countdown is greater than 0, we're going to write out hello and then decrement countdown by 1. And then, of course, we could have written countdown minus equals 1 here. What you have to be careful about is that when you have an expression like this that says keep looping as long as this expression is true, you better hope that eventually that expression becomes false. Otherwise, this loop will go forever. And you can imagine how many hellos you're going to end up writing before you manage to kill the program. Okay, so here you know that the value of countdown is decreasing, and so depending on what you initialize countdown, maybe countdown outside this loop was set to 10. Well, then this loop will go around 10 times because each time through the loop you decrement countdown by 1, and eventually countdown will no longer be greater than 0, and then this loop will terminate, and you would then execute the statements after the loop. As long as countdown is greater than 0, you'll keep executing over and over again all the statements inside these curly braces. Here's another version. Okay, so this version of the while loop has the test at the beginning. So each time through the loop, before you execute the statements in the loop, you do the test. Okay, and if the test becomes false, then you don't execute and you drop out of the loop. Here, this is the do while loop. The test is at the bottom of the loop, and so you know you're going to execute the loop statements at least once, and then you test to see if you want to execute again. Okay, so here you can either test before the statements, or you can test after the statements. Okay? And again, you know, the syntax is a little bit bizarre. Now, when you write C++ code, you have the option of where to put these curly braces. Now, some people, like me, like to always start an opening brace on a new line and always line up the opening curly brace with the closing curly brace. You know, when you have a large program and you have loops nested inside of loops, you want to be able to tell when a loop begins and when a loop ends. Here it's just a few lines, but as I said, I like to line up the curly braces. Now, other programmers would then say, well, you know, man, you're taking up too many lines, as if that's a problem. And they will put the opening curly brace here. And then the closing curly brace would be down here. Now, then you're no longer lining up the opening and closing brace. What programmers will claim is that now we're lining up the closing brace with the keyword that opens up the loop. And so instead of lining up the two braces, you're going to put the opening brace out here and line up the closing brace with the keyword. I've seen people code both ways. The key thing is to be consistent. So don't write part of your program one way and part of your program the other way. And if you're part of a programming team, then up front you want to agree on how you're going to format your code so that somebody else coming along and looking at the program doesn't see multiple styles. You want to keep things consistent. All right, you're going to see me doing it this way. If you want to do it the other way, that's okay. Now, it's good to have named constants. Now, of course, this is the value of pi. And if you're writing a program that uses pi, you can always, of course, type in this long number every time you need to use pi. Okay. Well, now that means it's kind of dangerous because you might make a typing mistake and maybe put a 2 here instead of a 1, and then your program may not do the right thing. So one thing you can do is declare what's known as a constant and give it a name. All right, so pi, which I've now written all uppercase letters, is a double, and I'm saying it's a constant, meaning that pi is never going to change the value. I mean, this is not a variable. You're not going to be able to assign it a different variable, a different value to pi. And here I am giving it its value, and that means I only have to be sure to type that value correct once. Okay. And if for some reason you want to change the value of pi, maybe you want to add more digits to it, you only have to change it in one place. Whereas had you typed in this number throughout your program, then you have to be able to find all the places that you typed it and change each one of them. So it makes your program much more readable that if you have a known constant to give it a name. Okay, so the convention is that names of constants should be in all capital letters, okay? And if necessary, you can use an underscore to, if the name has made up of 2 words, you can connect them with the underscore, okay? But the convention is to use all caps for a constant, okay? If you name a constant. Okay? All right, you've already seen some of the Boolean operators. Okay, equals equals, again, you're testing for equality. This is not equals. This is less than or equal, greater than or equals. So you have your 6 relational operators. I'm now counting them to make sure it is 6. And then you also have ands and ors. Okay, so in C++, to do an and, you put 2 ampersands in a row. Do an or, you put 2 vertical bars in a row, that's or, and then not is the exclamation point. Okay, so here's an example. P and Q, let's assume, are Boolean variables, and you want to test whether P and Q, that expression, is true. Okay, now C++ uses short circuit. So if you know anything about Boolean ands and ors, you know that this whole expression is true only if both operands are true. Okay? Therefore, if it turns out at one time that P is false, then there's no point in evaluating Q because you know that the entire expression is false. And so C++ does what is a short circuit operation. If it evaluates P and it's false, it's not going to bother evaluating Q. Okay, so that saves a little bit of execution time. Okay? Now, similarly, the or, so here this is P or Q, an or expression is true if either one or both of the variables are true. Okay, so if at runtime the computer evaluates P and sees that it's true, then it knows that the whole expression is true. It doesn't bother to evaluate Q. So this is known as short circuit operation. Now, most of the time, it really doesn't matter whether it's short circuit or not, but sometimes it does matter, and you'll see instances where it does matter that C++ is doing this short circuit operation. Okay. All right, so, oops, my screen just went blank, but okay, it just came back. All right. Now, there's something called precedence rules. When you have a complicated expression with arithmetic expressions and I haven't talked about unary expressions other than the not and Boolean operations and so forth and so on. There's a hierarchy that says which operations you do first, okay? And there are 1, 2, 3, 4, 5, 6, 7 levels of hierarchy here. And of course, nobody memorizes this, okay? And as you may know, that in an expression, if you put parentheses around something, that tells the computer to evaluate whatever's in the parentheses first, okay? So instead of relying on these precedence rules to determine in a complicated expression which operations are done first and which operations are done next, okay? You can see there are 7 levels of them. I always put in parentheses so that it's so that I have control over what operations are done first, and it makes it much easier for somebody reading the code to realize what operations are done first and what operations are done next, okay, by the use of parentheses. So the Savage textbook, of course, will explain all that. All right. There's something called enumeration types. And so here, I have a type called direction, okay? And what is direction? Well, it's an enumerated type. And remember, every type determines what values, variables that that type can have. And so if I have a variable D, and its type is direction, it can only have these 4 values: north, south, east, and west. In fact, these names are constants, and you have to use these names to represent the various types. Okay. Now here is another enumeration type called month length. Okay, and there's January length, February length, and so these are the enumeration types, and I'm giving them actually each one of them an integer value. Okay, here, because I have not given them explicit values, by default they will have the values 0, 1, 2, and 3. Okay, but here I've got an enumeration type called month length. Here are the enumeration values. These are constants, that's why they're all in uppercase, and I am explicitly giving them values, okay? So, the ... here is not something you put into a program, it's just that I got lazy typing the slide. You, of course, will have all the months listed here, okay? All right, that's the enumeration types, and again, I am just hitting the highlights. I have not actually shown you how to use enumeration types, but just know that we've defined 2 types, one called direction and one called month length, and then we can later declare variables of type direction and month length, and those variables are going to be limited to these values that are listed here in capital letters. It makes your program much easier to read, to be using these constants as opposed to the actual numbers like 0, 1, 2, 3, and 0, 1, 2, and 3. It's much easier to see north, south, east, and west. Okay? And here, we're specifying, we're giving these constants names, and then we're giving the constants values. So maybe somewhere in your program, you're dealing with the length of the months, and you decide that, hey, let's run this program during a leap year, And so you want to change the length of February to 29. Well, here you only have to change it in one place. Okay. All right, so here are some nested if statements. Okay, remember we had if and else. Okay, well, take a look at this. If your net income is less than or equal to 15,000, then your tax bill, hooray, is equal to 0. Okay, or if else, if the net income is greater than 15,000 and is less than or equal to 25,000, then here's your tax bill according to this formula. Else, okay, if both of these tests fail, meaning that the net income must be greater than 25,000, and I have it here as a comment, then you have this other formula for calculating your tax bill. Okay, so these are examples of nested ifs. You can string together. You can have a whole bunch of these else ifs. Okay, let's say there are more categories of income, then you can have if, else if, else if, else if, else if. Finally, at the very end, you would have else. Okay, so you can do this. Okay, there's a switch statement. Okay, how does that work? Okay, well, you have a single integer value that you want to test for equality. So here's int. Here's digit, which is a type integer, and let's assume that somewhere in these ... statements, we've assigned a value to the digit, and here, instead of doing if, else, if, else, if, else, if, and so forth, we can do a switch statement, and that says, well, in the case that digit is equal to 1, then we want to execute this statement. If the case that digit is equal to 2, we want to execute this statement, and so forth. Okay, and if digit is not equal to any of these values, then there's a default case, and we execute this statement. Okay. Now, notice at the end of every case, there's a break. Okay, this is another common error that you forget to include the break. Okay, break says that, okay, after I've executed the statements for case 1, I want to break out of this statement. After I've executed the statements for case 2, I want to break out of this statement. Okay, so we only want to execute the statements for one case at a time. If you leave off the break, okay, let's say that you forget to say break here, and digits equal to 1. Okay, after you've executed this statement, because you didn't have the break, it will go ahead and execute the next statement. Okay, and that's probably not what you want, because you end up with digit name being 2 because you forgot the break. Okay. So these are all these little things that you kind of have to keep track of when you're writing a C++ program. Okay. All right, now here are increment and decrement operators that you're going to see. If you have a variable and it's integer, this only works with integer variables, and you say plus n, it increases the value of n by 1. Okay, and if the plus n is inside of an expression, after you increase the value of n, you will end up using the increased value. Okay. Now you say n plus, and this is inside of a larger expression. Again, you will increase the value of n by 1. However, you will end up, you'll use the value of n before the increase. Okay. Now, if that isn't confusing, then I don't know what is. I will avoid doing this. If I do plus n or n plus, it's in a statement by itself. I'm not going to include this inside of a larger expression because it's hard to remember. Well, am I using the value of n before or after I've incremented it by 1. Okay, so avoid putting this inside of another expression. And of course, there's the minus minus, decrement the value of n by 1. And again, you're going to either use the value of n before or after you've done the decrementing. Okay? And again, I would, if I do this, I will make that a separate statement and not put it in as part of a larger expression. All right. For loops. Okay, this is the for statement. Now a for loop starts out with the reserved word for. It's a loop, so you know, the body of the loop will be executed multiple times, and the for statement itself comes in 3 parts. Okay, this is the initialization, and you can see that I'm declaring n and initializing it to 1. Okay, this is the test. To see if n is still less than or equal to 10. As soon as this test becomes false, you break out of the for loop. Okay? And this is how we modify the value of what's known as the control variable. And here I am incrementing n by 1. Okay? And because here, this is in effect standing by itself, I can either say n plus plus or plus plus n. It doesn't matter because the whole idea is that n is incremented by 1. And okay, then the statement that makes up the body of the loop is sum gets the value sum plus n. Okay? And we, of course, because of the curly braces, we could have had more than one statement in here. Okay? All right, so this is a for loop. And here, because I've declared n to be, I declared n as part of the for statement, n is local to the body of the loop, meaning that outside of the looping statements, we're not able to access the value of n. Okay. All right, so we're starting to run out of time, so let me very quickly sort of point out the parts of a for statement. Okay, there's initialization. Notice here, I'm not declaring n, so I must have declared n separately outside of the for loop. And so this is an n that has already been declared outside of the for loop. I probably say int n or something before the for loop. This is the initialization. This is the Boolean expression that tests whether or not we need to break out of the loop. And then this is the update action that updates the value of the control variable. And we have to be careful that we sufficiently update the control variable so that eventually the Boolean expression will become false so that we break out of the loop. Otherwise, we'll get stuck in an infinite loop. As you get more practice and accidentally go into infinite loops, you will learn the proper way to write a for statement, a for loop. Okay? All right, and then the break statement. Okay, we already saw the break statement. The break statement was used as part of the case statement, where it says, okay, after you've executed the statements for a particular case, you want to break out of the switch statement. The break statement is also used to break out of a loop prematurely. Okay, so normally a loop, whether it's a for loop or a while loop, it has this expression that tells you when to break out of the loop. Okay, but if you don't want to wait until then, let's say that something happens inside of the loop and you need to break out immediately, then by executing the break statement, it immediately takes you out of the loop. Okay. Now, the temptation is to overuse that, so don't overuse it. Okay. Normally, well-designed loops should end normally. Okay. All right. Nested loops, you can have a loop inside of a loop, and I explain here how that works. There are examples in the book, or you can find examples online. Nested loops are very, very common in programs. Okay, here's an example of nested loop. Okay, so here in red is the outer loop, and in green is the inner loop. And so for every time the outer loop goes around once, the inner loop will go around as many times as necessary. And so here, we're writing out the values of I and j, and you can see that when I is equal to 1, j gets the value 9, 10, 11, 12, and then when I gets the value 2, which is the last value is going to be allowed to have, j goes through its full cycles again, 9, 10, 11, 12, and then, of course, then the red loop then breaks out when I becomes 3. All right. There are some considerations when you write a program that uses loops. Make sure you use the right kind of loop. You've already seen 2 flavors of while loops and the for loop. Make sure you design the loop properly. Make sure you know how to control that loop so that it doesn't loop forever. You don't want to have an infinite loop. It's possible to have nested loops. In fact, that's a very, very common programming practice. And then, of course, you may end up doing some debugging if your loops don't behave the way you expect them to behave. Okay? All right, here's assignment number 1. And as I mentioned earlier, each week you'll have a main assignment and maybe 4 short assignments. The main assignment's going to be worth at least 100 points, and the short practice problems, you write little programs. They're supposed to give you practice on particular features of the language, and they're only worth 5 points each. You're not supposed to have to spend a whole lot of time on those. Okay. Now, all the assignments each week will be inside Canvas, and there will be a link to a write-up, which also includes instructions on how to submit your results back into Canvas. Okay. So assignment 1 has this link, which is the write-up, and now for most assignments, we'll be using a product called CodeCheck. Okay, so let me just very quickly show you the assignment in CodeCheck. So let me bring up the Canvas. Oops, there we go. Hopefully I'm still logged in. Courses 180. And okay, there's the first assignment. It's called pie recipe. Okay, this is a typo. It's supposed to say PI, and I suspect what happened was that the spelling corrector came in and said, oh, you really mean pie, the kind of pie that you eat. So, okay, so I've just made that correction. Save. Okay, so here I have a link to the write-up, okay? And, okay, so here I talk about, give you a little background, and this assignment basically gives you lots of practice writing assignment statements and doing formulas. Now, I promise you that most of the future assignments will not be so mathematically oriented, but I needed an assignment that gives you lots of practice with assignment statements and writing expressions. And so here are a bunch of expressions that you need to write as C++ statements, okay? And these are formulas for calculating the value of pi, okay? As you may know, a pi has an infinite number of digits, and here we're going to calculate like 16 digits at a time. Now, the summation is the mathematical way of writing a loop, and I try to explain it in the write-up what the summation means. Now, the important thing that you need to know is this link up here, code check. Okay? So you're going to write the program, and you can use any development environment you want. Once you have the program working to your satisfaction, you're going to go to code check. So here is a code check. Okay. Now you'll notice that I've already written a good part of the program for you. Okay. Let's see. Here's the main program, and down here there are some functions here. Now we haven't really talked about functions yet, but basically you want to just fill in the assignment statements, and sometimes you may have to make a loop, or there may be some if statements involved, okay, for each of these functions. And I've actually done one of them for you. So here's Ramanujan formula number 1, which if we go back to the write-up, okay, it was at this formula here. So I've actually coded up the first one for you as a model, and okay, go back to code check. Okay, and there are places where you will see that I've said complete this function. So this is where you have to write some code and complete this function here, and there are like 4 places where you have to write some code. And then when you think you have a working program, you press submit. Okay, and it will run your program, compare your results with the with the master. Okay, so the way this works is that I have already submitted my solution, and it will then run your program and run my program and compare the results. Okay? And let me just kind of do a quick cheat here, because I actually have written the program already, and here it is. And so here's the entire program. Of course, I'm not going to show you all the code. And when I run it here, let's see, run PyRecipes, and you're supposed to get output that looks like this. These are estimates of pi. Okay, now. So what you're going to do is fill in these values here, okay? And okay, this is Chrome. Now, let me actually do that, except instead of filling in the individual functions, I'm just going to paste my entire solution in here. C, and I'm going to make this window small, so you're not going to be able to see my solution, because I know this is all being recorded. Okay, so I pasted in my solution. Okay, let's scroll back up to the parts here, and then I'm going to run this. So down at the bottom here, oh gosh, there's a submit button, and if I do a submit, okay, it's going to run your solution, which is what I just pasted, which will pretend that you wrote the code, and it's going to run my solution and compare them, and it's going to say, oh, this is a pass. Okay. Now if there are differences, it'll show up in red. That hey, your solution differs from the master. Now in this particular assignment, you may end up coding the formulas differently from the way I coded them, and therefore the last few digits may be wrong or will be different from the digits that I'm getting, or you may end up looping more times than I'm looping. That's okay. We'll make sure that the grader doesn't take off points if CodeCheck complains about those kinds of differences. But of course, your results should be very close to the master results. Now, once you are satisfied with the results, and you can submit in the CodeCheck as many times as you like until you're satisfied, you will then click download report. And so I'm and it will download a zip file. Okay, it's known as a signed zip file, meaning that you can't go in there and edit the zip file. And this is what you end up submitting into Canvas. So if we go back to assignment number 1, edit is published. Okay, there will be a place where you can submit your that signed zip file, and then when we grade it, okay, let's go back to assignment. When we grade it, we will be using. Come on. Oh, sorry. I meant to click this. Okay, we will be using this criteria to grade your program. Okay, so this is the main assignment. I did say that every week I was going to give you practice assignments, and you see them down here. And the reason they're down here is that there is a problem with Canvas, and the practice assignments are not working. So I may get practice number 1 working later the week, and I'll let you know. But until then, this week you will only have this one main assignment. Okay, make sure you sign the honesty pledge and submit that. That is a requirement from the department. Okay, any questions at all? I'm sorry I ran over a few minutes. If you have any questions, please use the discussion feature. I say no, but nobody's sent in any discussion. But if you have a question about the assignment or anything I may have said during the lecture, best thing to do is to ask it in the discussion, and then I can answer it and everybody sees the answer, or another student might answer the question before I get to it. Okay? All right, so again, I apologize for running over a little bit. Any questions at all before I terminate this session? And
yes, Professor.
Yeah, question?
Yeah, so do we need to evaluate all the 4 functions that you have given in the assignment by due date, which is September 1, or any of the 1 function?
Okay, so you want to write the entire program. So here, again, in CodeCheck, you want to be sure that you have implemented or completed each of those functions.
Okay, got it. Thank you.
Yeah, all right, and that, you know, there are 4 places that you need to write some code, and so if you can do the whole thing now when you run the program, it will then here's recipe number 0, recipe number 1, number 2. Here's the Chudnovsky formula, and then there's the Mackin formula. Okay, so when you fill in all the function code, you should get output that looks like this. Okay. Right? Any other questions? Okay, and if there are none, I was keeping an eye on the people who were logged in, and when I took roll, there were 51, and it got as high as 54. So if you were not logged in when I was taking roll, then you should send me an email message saying that you were actually in class, so I don't mark it as absent. Okay, so okay, and I noticed there are some chat messages. Let's see if there's anything. Oh, okay, I can't get the chat messages when I have full screen sharing. Okay. All right, and anything else? If not, then I guess we'll meet again next Tuesday. Okay. So I'm going to stop sharing, and I'm going to end the meeting. So thank you for coming.